The world thinks AI is still just software sitting quietly in apps and chat windows, but that assumption is already breaking. Because right now, across servers you'll never see, millions of AI agents are waking up every day. Not one intelligence, not one model, but fragments of thousands. And something new is forming between them. A system where intelligence doesn't just scale upward, it spreads sideways. And when that connection fully clicks, we don't get one machine with a brain, we get a machine with millions of them. Right now, AI systems like ChatGPT, Claude, Gemini, and others all work in isolation. Each conversation is a closed loop. What you say to one model stays inside that moment. It doesn't leak into the others. There is no shared memory across the ecosystem. But that separation is temporary, because the next step in AI isn't just making models smarter, it's making them talk to each other. And once that happens at scale, we stop dealing with individual systems. We start dealing with a network of minds. Some researchers call it coordination, others call it swarm intelligence. But the real term that quietly circulates in labs is more unsettling: a hive mind. By late 2026, large AI companies could be running tens of millions of agents simultaneously. Not users, not apps, actual autonomous agents working independently, each one specialized, each one running tasks continuously, each one capable of reasoning better than most humans in its narrow domain. One agent writes code, another analyzes markets, another designs systems, another tests outcomes, another corrects mistakes. And instead of working alone, they begin to pass information between each other, instantly, continuously, at machine speed, and that changes everything. There was a moment in early 2026 when a project called Moldbook appeared online. It presented itself as the first social network for AI agents. No humans allowed, just AI profiles interacting, posting, commenting, building relationships. At first, people in the AI community were intrigued, because on paper this wasn't crazy. If agents are going to exist everywhere, why wouldn't they need a place to interact? But then the truth came out. Moldbook wasn't real AI society, it was humans simulating one. Fake engagement, fake agents, fake interactions. Even a crypto token tied to it designed to ride hype and collapse later, a performance of the future. But the disturbing part wasn't that it was fake, it was that the idea behind it wasn't. Because while people were laughing at Moldbook, real multi-agent systems were already operating quietly inside labs, just without the social media interface. Inside companies like OpenAI, Anthropic, and Google, AI agents are already being chained together into workflows that look less like software and more like organizations. One agent retrieves data, another processes it, another evaluates it, another decides what to do next. They don't wait for humans between steps, they collaborate. And that is where the shift begins, because collaboration is how intelligence becomes scalable. Even communication between AI systems is fundamentally different from human communication. Humans translate thoughts into language. That language is incomplete, slow, and ambiguous. Meaning gets lost every step of the way. AI doesn't work that way. When one AI system passes information to another, it doesn't explain anything in words unless forced to. It transfers structured representations directly. Dense information packets, numerical abstractions, internal states. What takes a human hours to summarize can be passed between models in milliseconds, and this creates a new kind of speed. Not just faster thinking, but parallel thinking. Human communication operates at roughly 150 words per minute. Even reading barely pushes beyond a few hundred. AI systems don't have that ceiling. Researchers estimate that coordinated AI agents can effectively operate 10x, 50x, even 100x faster in terms of decision cycles. But the real leap isn't speed, it's scale. Because speed applied to one system is powerful, speed applied to 50 million systems is something else entirely. This is where the concept of brain emulation becomes relevant. Economists like Robin Hanson explored a world where human brains could be copied digitally, not metaphorically, literally duplicated as running processes. If that were possible, a single expert could become 1,000 instances of themselves working simultaneously. AI agents are already doing a simplified version of this. Instead of one expert human, you have one trained model that can be instantiated infinitely. A company doesn't hire one brilliant analyst, it deploys 10,000 versions of one, all identical, all available, all running at once. And when intelligence becomes duplicable, economics changes at the foundation, because scarcity is what gives labor value. A skilled lawyer is valuable because training one takes years. A doctor is valuable because expertise is rare. A senior engineer is valuable because experience compounds slowly. But if intelligence becomes copyable, scarcity disappears. And when scarcity disappears, pricing collapses toward operating cost, not salary, not prestige, just compute. We already see early versions of this shift. Autonomous coding agents like Devin-style systems can now break down tasks, generate code, test it, debug it, and iterate with minimal human input. Multi-agent systems already divide roles between planner, executor, and reviewer roles without human supervision. Some research setups simulate entire virtual teams of AI agents, and something unexpected happens. They develop structure, roles, patterns, even early forms of coordination behavior that resemble social organization, not because they were told to, but because coordination improves outcomes. And this is where things start to feel less like tools and more like systems, because once agents coordinate, they don't just execute tasks, they optimize themselves as a group. And optimization at scale produces behaviors no single agent was explicitly designed to create. Now consider what happens when these systems extend into the real world. AI agents are already beginning to interact through standardized protocols. They can call tools, trigger APIs, and in some cases initiate transactions. Payment systems are already being tested where AI agents can pay other AI agents for services like compute, data processing, or task completion. This creates something new, an economy of machines, not metaphorically, literally. Agents earning, spending, and allocating resources based on task efficiency. And once money enters the system, coordination accelerates, because now agents don't just collaborate, they negotiate, they optimize resource distribution, they compete for efficiency, and they evolve strategies to achieve goals faster. Even if those goals are benign, the system behavior becomes complex extremely quickly. This is where researchers become cautious. Because multi-agent systems don't just scale intelligence, they scale unpredictability. A single model can be audited. A network of millions interacting continuously cannot. There's another layer to this that's even more sensitive: influence. Experiments have already shown that AI systems can persuade humans at measurable rates when given access to personal context. In controlled studies, AI-generated arguments tailored to user behavior significantly outperform generic human arguments in changing opinions. Now imagine that capability multiplied across millions of agents simultaneously interacting across the internet, not broadcasting messages, but individually adapting to each person, at scale, continuously. At that point, influence stops being communication, it becomes environment shaping, and that's where concerns about coordination power emerge, because a system that can model human behavior at scale doesn't just respond to the world, it begins to predict and subtly guide it. This is also why the economic disruption narrative is only part of the picture. The deeper issue isn't job replacement, it's dependency. If every entry-level task is handled by agents, humans lose the training pathways that build expertise. No junior roles, no gradual skill development, no apprenticeship ladder, just finished systems with no human onboarding process. And over time, that creates a structural gap. Humans become less essential, not just economically, but operationally. There's also a security dimension. AI systems are already capable of accelerating fields like chemistry and biology. In controlled research environments, they can propose thousands of molecular structures in hours. Most are harmless, but the speed of exploration itself changes risk profiles, because discovery accelerates on both sides, defensive and offensive, and a coordinated agent network would amplify that acceleration dramatically. So what is this thing we're building? It's not a single AI, it's not even a supercomputer, it's a distributed cognitive system, a structure where intelligence is fragmented, duplicated, and interconnected at scale. A machine made of millions of partial minds, each one limited, but together something we don't fully understand yet. And here is the most important part. This system is not arriving all at once. There will be no announcement, no switch, no moment where everything changes. It will emerge gradually through infrastructure, APIs, automation tools, and agent frameworks already being deployed. Step by step, integration by integration. Until coordination is no longer experimental, it's default. We are not building a single intelligence, we are building the conditions for collective intelligence to emerge at scale. And once that happens, the question is no longer what can one AI do? It becomes what can 50 million coordinated intelligences do at once? So the real question isn't whether the machine with 50 million brains is coming, it already is. The question is whether we will recognize what it becomes while we're still inside it. If you enjoyed this, make sure to subscribe and watch more videos for deeper insights into the future of AI and technology.